Welcome to my backyard. Today I want to introduce my new off-grid shop. Yep, it's a shed. 7 by 15 feet, roughly interior space. I've already gone ahead and put these lights that automatically turn on during the night, so it lights up the front of the shed. And this whole project will be revolving around creating a workshop that will be housed in here, and you're going to see my lathe and my milling machine and all these tools are going to go and live in here now, and they're all going to be run off of solar panels. I've noticed in the last few years that used solar panels are excessively cheap. I actually managed to pick up a couple of solar panels for about $60 a piece. And looking through all my junk, I found a 1500 watt inverter, which actually happens to be a Xantrex, which is very nice and it works well. And my father gave me a solar panel. He gave me a bunch of lead acid batteries to try and resuscitate. This is a low-cost project. A lot of the materials I will be using in this will be recycled, and a lot of these materials are going to be, free to me kind of deal. However, anybody should be able to actually replicate something like this for at least the off-grid part for maybe a $300 to $500, I think. As it stands right now, I have about $150 in there. The inverter, as I said, I remember buying it with some other junk for, I think I paid about $20 for the inverter, which is, it's a great deal. And the two solar panels are about $120, and I think I have some cabling and miscellaneous, so maybe I'm closer to $200 right now. The batteries were free to me. I got 6 batteries, only 3 of them are really somewhat working. The other 3 are not. They don't hold a charge. I've been boiling them up and they still don't hold a charge, so I'm not sure what I'm going to do about those. Eventually I guess I'm going to be replacing them. The idea is to only replace what I need to replace and use what I have, and only buy as much as I need to buy. And with that said, I've started to clean out my shed, and I moved a bunch of the lawn equipment and things like that I've stored in here. I moved them to the back of the shed, between my fence and my shed, and I created this little tarp covered thing, and there's a couple of solar panels on top. So with that said, let me give you a walk around and what today's project is going to be about. So you guys may remember my portable solar generator here. This has been charging off the solar panels, so even this video is being run off of solar energy. And that's my tripod with a 3D printed leg that holds an old computer monitor with an adapter. It's also running a small battery that's also been solar charged, so I'm taking the off-grid idea as high as I can. And this is the shed. I wanted to give you guys a little bit of a look through on my lamps. These were recycled, a little coat of paint, 3D printed the actual holders. I have 4 of these. They came off of ceiling fan that was being thrown away, and 12-volt batteries. These actually look pretty nice at night, and there's 2 of them, both sides of the shed. And this is the back of the shed. That's the tarp area, and we have the solar panels here. And of course, these solar panels are not in the optimal position, but then again, what things in this world are optimal? The other part of it that I wanted to show you, the shed is still a bit of a mess, but not completely. This is my battery bank inverter setup I have right now. This is actually a jump starting battery that I use for vehicle recoveries, but those are the three batteries I will be using in parallel to feed that 12 volt 1500 watt inverter. That solar charge controller my dad gave me as well. I bought a couple of $10 or so energy meters. So this is input voltage. It's late in the evening, so I'm only getting about 5 watts. I've only collected about 4.6 kilowatts of energy out of this, so this has only been going on for a couple of days. This is the consumption meter, so I've only been using about a half a kilowatt so far, and this is one of the batteries I've been charging. So I have some of these things, and the idea is to gather all this junk and put it in a case that, number one, it's safe, number two, I can service it, and number three, I get it off the floor. Because having a bunch of wires hanging around the shed like this it's not conducive to doing any work. So with that said, I'm going to be taking this apart slowly and bringing all the components in. And for those of you who were wondering, this is why the inverter was so cheap. It was actually part of another battery bank that went bad, and this is the front panel, and those are 110 volt wires that are exposed. This outlet system will be going away. So with that said, let the project begin. This is the box that's going to become the, I guess, the power station for the off-grid workshop. As of now, it's been serving as my stand for my horizontal vertical bandsaw here. I actually really like this saw, but it could really use a rebuild and good cleanup. So as of now, it's going to get put away in the corner. It's almost as if this case was made for these kinds of batteries. These are Group 31 batteries. These are the 3 dead ones, and they look pretty good in there. I threw in a coat of paint. I 3D printed a bunch of these fittings for these 2 panels, this fuse block, these terminal posts, this XT90 connector over here, and we have a output fuse, charge controller, USB, power port. This is 300 amp going from memory, shunt capable meter basically, and this is 100 or 150 amp. I believe this is the 150 amp version. This is for the input, and it counts watts, and this one also counts watts, but it's the output. I have a voltmeter here with a button to turn it on and off that will connect across these 2. It'll give you what the input voltage is on the solar array. This charge controller is not an MPPT. It's a PWM charge controller. It's over 10 years old, but it was never reused, and it's done a reasonable job so far in charging. It's 30 amp rated, and of course the fuse is going to be 50 amps for this, but the fuse will sit before this. And on the side, also 3D printed an adapter, a set of outlets that will connect to the internal inverter. As of now, there are no connections, as you can tell. It's just these loose wires, and on top I took out one of the dividers that was original to this box, and I pushed it all the way up. It's about 2.5 inches or 3 inches, yeah, roughly about 3 inches down, and this is what's going to house the inverter. The inverter, I said before, I believe I said it was a 1500 watt. I looked it up. It's actually a 1330 watt inverter, so it's got a maximum output of about 11 amps. Still, I think that should be just enough to get my machine shop functional, and time will tell. Now I gotta do the internal wiring here, so all this stuff can actually function, as well as do some internal wiring for the actual battery bank itself. I have a few ideas on bus bars that I will be using for this. As of now, there will be 3 Group 31 batteries for it, and they're not the highest quality batteries. They're also roughly around 10 years old, and I had to recover them using basically I charged them for over a month until they resurrected, and out of 6 batteries, 3 are mediocre, let's put it that, which is fine. As you can tell, the job has not been the best in the world. Don't really care. I'd like to also install some sort of top over here so I can use this as a workbench. And so without further ado, I'm going to do the wiring, and I'll bring you back once the wiring is done, and I'll explain what it does and how it looks like and all that. So I wanted to show you guys something. These bus bars, I've made them out of copper pipe, and I'll show you the process on how I've made a lot of these. I made the back one here, main bus bar up here. So basically anything that's very high amperage. I believe this is 1/2-inch copper pipe, and I just crush it nice and flat. I drill the holes wherever I need them, and I make the connections. These terminals here, I 3D printed them, and there's these are M6 screws and nuts, and basically they're standoffs. They're screwed onto directly to the wood here, and I should have enough room for 3 batteries here, and if I add a second level I should have enough room for another 3 batteries, so 6 batteries in total. So pardon the absolute mess. This I've cut it to roughly the right size that I need. This is my discount store arbor press. Supposedly it's a 1-ton unit. Has not been bolted down, but basically I do this. It's kind of difficult to do it on camera. Once you're done with the first side, it'll probably be curved like this. So I go through the back. I should really bolt this thing down. So on and so forth, and that straightens it out. At the end you should have something like this. So what I'm going to do next is I'm going to mark where the holes need to be. So this is my discount tool store. It's a reamer bit. It's not a step bit, it's all the way smooth. And before you say, well, you should probably take a known size and drill it, this is copper. It's going to grab that bit. It's either going to stall the motor, or it's going to yank this out of your hand and cut you up. Either way, it's not great. This actually goes in smooth, but it leaves a very nasty burr. One more thing, this drilling operation does leave the copper fairly hot, so you should know that. So before installing them, I need to deburr these of my bit here. Watch out, even the deburring operation leaves a pretty nasty burr. Copper tends to work harder. So there we go, one bus bar. Up here there's another bus bar that has the current shunts for the 2 meters. So this one over here, the one in front, this is going to be the charge meter, and the discharge shunt is in the back. So I double checked, this is 100 amps and the one in the back is 300 amps. So I should have more than enough meat on these bars to supply that kind of amperage. Okay, the primary bus bars are here. If I were to do a second level here and put a couple of spacers here so I can put more batteries on top, the new batteries would get an L bar just like this, and it would get stacked on top of this. So an L piece just like that. I had no interest in making this all in one piece. I'd rather have it modular so I can actually service it. And the idea of this is eventually I will replace these batteries with a couple of lithium batteries, and this whole case will be a lot lighter weight to move around, although it's on casters, so it should move around even with 6 batteries in it. Okay, the majority of the wiring is complete. I have not wired the inverter just yet, and my USB charger with a voltmeter here. This can also be turned off. Power port. This is the output, so this is how much wattage I'm using, which is literally 0. The display here doesn't consume enough to even register here. This is a breaker, 50 amps. This is the solar input voltage. This is fuse box. So I have interior lights, side lights, blower. This is going to be for a heater, and a DC outlet, which is this up here. 2 spares, charge controllers here, small battery charger that's acting as a solar panel right now. It's putting in about 4.4 watts into the dead batteries that are in here. Those batteries are basically worthless at this point. And that's all the panel has. Oh, these are the actual outputs for these 3. They're XT60 connectors. And the highest fused one is going to be the blower. And that's a 20 amp fuse. And these are rated for 60 amps, and personally I've put 30 or 40 amps through one of these and had no real issues with it. So, and even this is probably not going to consume more than 5 amps or so at 12 volts. With that said, I'm going to have to finish the inverter wiring now and put this to bed. I figured let me show you guys the conclusion of this. Everything's been wired. I'm only feeding about 12.5 watts. I've collected close to 3 kilowatts of battery power. And unfortunately, the battery bank that I was planning on using, these 3 batteries, they weren't holding up very well. So I bought new batteries. So now the cost has gone up a little bit, and those are the batteries. There's 300 amp hour marine batteries in there. They're being charged by the PWM controller. Here's all the wiring. I've yet to zip tie everything up. The inverter actually is up there. It's been bolted in. There's a switch for it, as well as a battery meter. This battery meter is not very accurate because this inverter was originally bolted to a set of gel cells. and these are flooded, so the voltages are slightly different, and that's what that meter measures, is voltage. This meter here has been calibrated to measure the voltage of these batteries. It works okay, and as you can tell right now I'm using about 60 watts of power out of the side outlets. It's powering the shop light. It's also powering this light inside the shop, which is all fine and dandy. So this is the first part. This is going to be the beginnings of the off-grid workshop. So we have the power system. I should be able to run my lathe and my milling machine and all these on this. Time will tell. So like, share and subscribe, and come back again. This is going to be a series. Thank you.